Hey guys, making your benchmark review answer video. Been fighting a terrible headache all day, but I'm going to get this done. Let's see, let's choose a pointer. Let's use the green arrow for a little bit. So I love this. I know not everyone is a Harry Potter fan, but I am. The dotted line is actually called the altitude of the triangle. You'll learn that next year. Let's start going through some answers on the benchmark review. Okay, so it's going to be written out like so, and then my little system of using the highlighter, apparently I missed on this one. Should have a little highlighter bit right here. Why is it? Oh, duh. There we go. Anyway, so exponent laws. So we're squaring what's inside the parentheses. In other words, multiplying it by itself. So remember, you could always write it twice and multiply it by itself if that makes it look easier for you. But 3 squared is 9. X to the negative 2 squared, power of a power multiply, is x to the negative 4. So we rewrite that 9 over x to the positive 4 because a negative exponent tells us how many times to divide by that x. That's why it goes down in that denominator. Another negative exponent, so you have the entire value to the negative 1 power. That's like finding the inverse, the multiplicative inverse. Take the entire value that we're finding the negative 1 power of, flip it. 1 over 4x to the third, and there you go, that was A. Excuse me. Alright, on to the next question. So again, more exponent laws. So we discussed in class that when you have a fraction to a negative exponent, that negative is like a reciprocal maker. It makes a fraction. So we're going to take the insides of this, we're going to flip it, we're going to make the exponent positive. Now you're squaring, so it's power of a power, so you multiply your exponents. Y to the 6th over x to the 4th. The area models, we saw these in class. We used the algebra blocks a little. We didn't get to use them as much as we would like. Hopefully we can do some more with them later in the year. I know some of you are probably groaning when you hear that, but you'll live. So when we multiply, we write a horizontal and a vertical component to the multiplication. So basically they're asking what blocks would be laid across the top and down the side to give us this product. So I wrote it out. Each one of these has a length of x, that's 7x. Each one of these has a length of 1, that's 5, so 7x plus 5. And x plus 2 on the other side, 7x plus 5, x plus 2, which was C. Another area model. For some reason, they like to make sure that we're extra confusing no matter what we do. Notice the shaded is x squared and the white one is negative x squared. Same thing over here, same thing over here. So you have to look at the key. You may not assume that the white one is the positive and the shaded one is the negative. You have to look at the key. We have 4x squareds, so that's 4x squared, a positive 1, and negative 2. Now each of these choices is written as a sum of 2 polynomials, so go ahead and add them. We can see that these two, A and C, were linear. This one has a positive 3, should have been a negative 1. Correct answer is D. So it's a question where you're interpreting an area model and adding like terms together in a polynomial. Division by a polynomial. This looks weird, I know, but isn't it the same thing as taking the insides here and putting it over 7t squared? So I just wrote it as 3 separate fractions, and all you're doing is using your quotient rule, your quotient of powers rule. So 63 divided by 7 is 9. T to the 6 minus 2, so t to the 4th. 28 over 7 is 4. T to the 4th over t squared, so t squared. And 14 over 7 is 2. T squared over t squared cancels. B is the correct answer. Which polynomial cannot be factored of a set of real numbers? Well, in order to figure that out, you have to factor each one. So remember, these are 1x squared trinomials. These are easier than the ax squared, where the a is not a 1. This is just find factors of c that add up to b. So factors of 5 that add up to 6, 5 and 1. Factors of negative 4 that add up to negative 3, negative 4 and 1. Factors of negative 4 that add up to positive 3, just switch the signs of the previous one. Factors of 10 that add up to 6, well, the only factors of 10 are 1 and 10, 2 and 5. Neither pair is going to add to give you 6. Which of the following equals 3x squared minus 10x minus 8 when factored completely? So, factor it. You can multiply each of these out, but I chose to factor it. If you multiplied each one out, I'm sure you found your answer just fine, and you should have D. If you didn't, and you wanted to factor it, this is the process we should follow. Find AC. A times C, negative 24. Find B, negative 10. Find factors of AC that add up to B, which come out to be negative 12 and 2. Take apart the middle term, going backwards through FOIL, giving yourself 4 terms now. Take out the GCF of the first pair, factor by grouping. Take the GCF of the second pair. Notice that the parentheses are the same. 3x times x minus 4 plus 2 times x minus 4 is 3x plus 2 together times x minus 4, factored. Difference of squares in number 9. So you're finding the square root of x squared, which is x, the square root of 81y squared, which is 9y, 1 plus 1 minus, factored. And then this one you're going to factor completely, which usually should tell you that you're going to have to do more than one step. Or that it's a possibility you could be doing more than one step. Factor out of 5, leaving x squared minus 1, and then that's a difference of squares. Square root of x squared is x, square root of 1 is 1, 1 plus 1 minus. Cross out the things that don't match, the only one that matches is b. Adding and subtracting polynomials. So we have to add the first two sets of parentheses, and then it's minus 2d minus a minus 1, which is plus 1, and then it's just combining like terms. The linear terms, the first degree terms, all are underlined once. 5d plus 4d is 9d minus 2d would be 7d in the middle. 6d squared has no like term. Negative 2 plus 1 comes out to negative 1. D is the correct answer. I used FOIL to multiply these two binomials. 2x times x, 2x squared. 2x times 3, 6x. Negative 1 times x, negative 1x. And negative 1 times 3, negative 3. Combine the like terms in the middle. Multiplied. And C is the correct answer. Okay, so we have a trinomial and we're dividing by a binomial. And then we have plus a binomial. Now this looks weird and it is not something we've really discussed much. So this is what they call an application problem. They're trying to get you to apply your knowledge and then apply other knowledge you have in algebra to figure this out. So what you're going to do with something like this is you're going to factor this top part. All right. If they give you a fraction that looks like this, you are guaranteed in Algebra 1, you are guaranteed that this binomial is one of the parts of this when you factor it. So that's going to help you factor. It's going to make you faster. Because you can automatically write the x plus 2, then you just got to go back and figure out this one. So in this case, when you put in the x plus 2, you're going to ask yourself, well, what times 2 will give me a negative 14? That's a negative 7. And what times x will give me a 2x squared? That's a 2x. So you can factor that faster, knowing that one of the binomials is x plus 2. Now, because this is multiplication in between here, the x plus 2's can cancel. They can cancel altogether, leaving you 2x minus 7. And then you add the x plus 3 that came after, and you add your like terms, you get 3x minus 4. So if you had that figured out before you got to this problem, before you got to this part of the video, I'm very impressed, because that was a challenging question. This one is, again, dividing. So divide, 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 divide. I only had to do 2 terms, though, because by the time I did the first 2 terms, I had identified which one was my answer. That is the benefit of multiple choice, and you do want to use that to your advantage. Okay, I know we're hauling through this video, but, you know, it's almost 1 o'clock in the morning, so it's probably a good idea I get done and go to sleep. This is a concept that you guys can rest assured will not be on the benchmark or the critical skills assessment, whatever it's called. It will not be on there because we haven't covered it yet. Okay. Oh, I just gave my little smiley face a dimple. Okay, anyway. A zero of a function is the x value where y equals 0. So when you're looking for a 0 of a function, you're going to look on the x-axis. And you're going to look for the x-intercept, because that's where y equals 0. And this is the only one out of the 4 that has an x-intercept of 3. Again, we haven't actually learned this yet. Not going to be on your critical skills assessment, and if it is on there, then you have my permission to either guess or skip the question. Or try to remember this video, which would probably be the smartest of the choices, but don't stress about this concept. Not on your benchmark, whatever it is, thing. Same thing on number 16, because we haven't talked about graphing it. I think you could probably figure it out pretty quickly if you use your graphing calculator, but it's not something I can go over in a video. Number 17. Number 17 asks you to find f of -1. This is review. We've seen this before. That just means plug in the -1 for the x. And remember to use your graphing calculator to your advantage. I would literally type it as you see here. I'm not saying you can't do the math without it. I'm just saying, why not use your calculator if you have it? So -1 cubed is -1, plus 2 times -1 squared is 1, so that's just a 2. -1 plus 2 is 1, minus 3, -2. C is the correct answer. A set of data shows a pattern where every element of the range is the sum of 8 and the square of the domain. This is just getting you to remember domain and range and translate a expression. So the square of the domain would be x squared. The sum of 8 in that would be 8 plus x squared. And the range is y, but they don't give you it in terms of y. They used f of x. So f of x equals 8 plus x squared, or x squared plus 8b is the only answer that matches. Okay, I think, let's see, 19, 20, 20, 3 more questions, I think? Yeah, 3 more questions. Which function represents the values in the table? I started off by identifying that this had to be a direct variation. And a direct variation will not have a y-intercept other than 0. And I knew that because it goes through the point 0, 0. So I eliminated b and c based on that. And then I looked at what the pattern is. 2 times x would be -4, not -1. But 1/2 times x is -1. And 1/2 times this x is 1. So the only answer here that matches is D. Solution to the system of equations. This was set up nicely for substitution. So I took 1/3 x minus 1 and plugged it in for y, because y equals that, so you replace y with it. Distributed, and we got x minus x plus 3 equals 5. X minus x cancels. 3 most definitely does not equal 5. This system has no solution. You can alternately take this second equation and solve for y, and you'll find that the two lines are parallel because they have a matching slope. So you could also do it that way. Last question. What appears to be the solution to the system of equations shown in the coordinate plane above? Well, this just requires us to know what we mean when we say solution to the system. The solution to a system of equations is the point where the two lines in the system of equations cross. Now, or it could be all the points on the line if it's one line, or like the previous question, no point at all because there's no solution. So in this case, they cross. You can clearly see that they cross. So really all you're doing on this is reading off a graph. And the closest point out of these 4 that matches this ordered pair, first of all, it's the only of the 4 points, I just realized this, that's in the third quadrant. First, second, third quadrant, fourth. It's the only one in the third quadrant, so it's got to be that. Nothing else could have even matched. So I would hope all our systems questions will be that happily easy. Okay, I don't know how long this ended up. Hopefully not too crazy long. The second part will be posted for you sometime during the weekend. See you guys in class.